So today is going to be 31-4. We're going to be looking at right triangle trigonometry again, but this time we're going to use our three trig ratios and examine the inverse. So we're going to use those inverse functions to determine unknown angles. So when we use these trig ratios such as sine, cosine, or tangent, we're comparing the sides of a triangle from a given angle. So for this example here, if I said that this is theta, and I want to compare my two given sides here, I can compare opposite to the hypotenuse, which I know is to be 5/3. But it's useful to be able to compare those ratios, but just understand we can take this a step further and we can actually find the value theta, or my angle, and we use that by using the inverse. So then that means that the inverse of a sine of a ratio, we can say that's arcsine, is the same as sine inverse of 5/13. So it's the inverse of that ratio. And now there's a few things that students typically get confused about, and I'm going to make sure I go over those so that we don't get confused here. So let's take a look at ways that we can write this. So to signify what my inverse is, I could say sine inverse, cosine inverse, or tangent inverse of a given ratio. Or I can say arcsine, cosine, arctangent. Both of those are correct. You can write them as both. They both mean the exact same thing. So it just depends on how you want to write it. I like using sine inverse, cosine inverse, and tangent inverse. But if you wanted to do it this way, go right ahead. Now the first misconception that a lot of students make, they say sine inverse is the same as cosecant. Like the sine inverse is the same as cosecant. It does not. Those are not equal statements. They are not the same. Sine inverse is not 1 over sine. Do not do that. That is poor logic, and you will get whatever problem that you're trying to work through incorrect. Do not do that. Number 2, the way that you need to view this is it's the sine of an angle, and I'm just going to use this example of sine, equals a ratio. That means that the sine inverse is always going to represent an angle. So it's going to be the sine inverse of a ratio is going to equal an angle. So the inverse means angle. Sine, non-inverse, references a ratio. The second, number 3, if I say the sine of theta equals 3/5, that means that the cosecant of theta equals 5/3, right? Because we said that they're reciprocals of each other. That's why I flipped them. Notice theta stayed the same, which means that the sine inverse of the ratio will equal theta. The cosecant inverse of a ratio will still equal that same angle. The angle doesn't change. It's only the ratio that changed, and that's why the ratios in both of these changed. Sine references ratio, inverse represents angle. Get that in your head. You have to understand that. So let's look at our first example here. It says find theta in degrees. So once again, I have that right triangle, so that means SOHCAHTOA it applies, it works. I need to establish a relationship, because once I establish a relationship, I can work through that and find what theta is. So in this case, I have opposite and I have hypotenuse, so I can use a sine relationship. So I'm going to say the sine of theta equals opposite over hypotenuse. Now to get that theta by itself, I have to get rid of this sine. So to get rid of that sine, this is where I'm going to use the inverse. So I'm going to do the inverse to both sides. So I take sine inverse to both sides. Now, sine is what we call a left-handed operation. So because I took the sine inverse, I only can apply it on the left hand, and so that's going to cancel out here. So that sine inverse and that sine cancel out here, and I'm left with theta. And so I'm going to get theta equals sine inverse of 20/29. Now entering that into my calculator, now remember it says in degrees, so that means I need to switch my mode to degrees. This is going to give me 43.6 degrees. Number 2, finding the measure of angle P. So finding P, I have my adjacent and hypotenuse, so this is going to be cosine. So for cosine, I'm going to say cosine of P, right? I have to establish my relationship equals adjacent over hypotenuse. So then, to get this P by itself, I have to get rid of that cosine. You take the cosine inverse to both sides, which is a left-handed operation. And so I'm going to get P equals cosine inverse of 15 over 17. I enter that into my calculator, beep, bop, beep, and you're going to get 28.07 degrees. Now this is what I did here. First step, I tried to create an equation or establish a relationship here. And so for this one, I said sine of theta equals opposite over hypotenuse. And so that's what I established. Sine of theta equals opposite over hypotenuse. Then step 2, I used the inverse to isolate the angle, and so that's why I did the inverse to both sides. I did the inverse and I did the inverse. Then once I had this statement here, I entered this into my calculator and I found the angle, which was step 3. And so kind of like replaying that for the next one, I established the relationship, cosine of P equals adjacent over hypotenuse. Then step 2, I took the inverse to isolate it, so cosine inverse and cosine cancel out. That's how I was left with P. So I get the cosine inverse of 15 over 17. Step 3, enter that into my calculator, and I got 28.07. Looking at this next one here. First thing I need to do is I need to establish a relationship. And so I have opposite and I have adjacent. So that's TOA, so that's going to be tangent. So I'm going to say the tangent of x equals opposite over adjacent. And so now I'm going to use the inverse to find the angle or to isolate the angle. So I'm going to take tangent inverse to both sides, right? It's a left-handed operation, so I get x equals tangent inverse of 15 over 20. So now I want to enter that into my calculator, and if I do that, step 3, I'm going to get 36.87 degrees, which is going to be my answer. For this last one here, if I want to find beta, I have my opposite and my hypotenuse. So this is going to be sine. So sine of beta equals 7 over 14. So now step 2, I want to use the inverse to isolate the angle. So I'm going to take the sine inverse to both sides. And so I'm going to get beta equals the sine inverse of 7 over 14. And so I enter that into my calculator, and I'm going to get approximately 30 degrees. That's going to be my answer. So let's do some application here. It says a ladder leans against a building, forming a 58-degree angle with the ground. The base of the ladder is 13 feet from the building. Determine the length of the ladder. So here's my beautiful building, and we said that we have a ladder leaning against it, and it forms a 58-degree angle with the ground. And we said that the base of the ladder, all the way to here, is going to be 13 feet. So I want to determine the length of the ladder, which is this value right here. So now with that, I need to establish that relationship. And so in this case, it's a right triangle, so SOHCAHTOA works. I have my adjacent and I have my hypotenuse, so I'm going to say cosine. So the cosine of 58 degrees equals adjacent over hypotenuse. Now solving for x, so I got to multiply both sides by x and divide both sides by cosine of 58. And so I get x equals 13 over cosine of 58. This value here into your calculator, and you're going to get 24.532 feet. And that's going to be the length of my ladder. To close today's lesson, what did we learn today? Well, we talked about the inverse ratios of our trig functions, and we used those to find the missing angles of a right triangle. Now I want to hear from you. What do the inverse ratios represent? Now you may have to go back through and take a look at the notes and kind of like what we talked about, because they mean something very specific. Now this does conclude our lesson. If you have any other questions, please leave them in the comments.